Phenology is the scientific study of the timing of recurring biological events in nature, like when a flower first blooms or a bird migrates. To track these biological timelines over long periods, modern ecologists rely on a vast and rather unexpected wealth of historical data. This information doesn't come from high-tech laboratories or government archives. It comes from hundreds of years of personal records kept by amateur naturalists. We're going to look at exactly how researchers take these highly subjective historical diaries and hobbyist notes and process them into rigorous, predictive climate models. It is a process that translates centuries of anecdotal, backyard history directly into actionable environmental science. The baseline for these ecological datasets often starts with conventional historical journals. Take the Marsham Estate records in England, offering a continuous log of biological tracking maintained by successive generations of a single family for 211 years. Measured precise tone. They recorded specific floral markers, like the exact date the first wood anemones flowered on the estate each spring. They also tracked faunal markers, carefully noting the specific days when local rooks began building their nests in the branches overhead. Moving into the mid-20th century, researchers found invaluable data in the meticulously kept beekeeping notebooks of Walter Coates, spanning from 1941 to 1969. Today, scientists are actively hunting down even more informal, domestic records like these. One man submitted 30 years' worth of old kitchen calendars. His only notation was a mark indicating exactly when his neighbor's magnolia tree flowered. These highly localized, intensely personal observations serve as the crucial base units ecologists need to reconstruct long-term ecological baselines. But this data mining extends far beyond personal journals. Researchers are extracting valuable metrics from unconventional cultural events, including annual Alaskan betting contests. On the Tanana River, participants place bets on the exact moment a specially erected wooden tripod will fall through the thawing river ice. Because this competition has run continuously since 1917 under consistent rules, it has inadvertently created an unbroken environmental ledger. By analyzing this betting data, scientists discovered that the river thaw now occurs 5 full days earlier than it did when the contest first began. Human recreational habits accidentally generated a highly precise century-long record of regional climate shifting. When ecologists aggregate thousands of these individual amateur records, clear hemispheric patterns emerge. This map of the Northern Hemisphere tracks standardized data points converted from historical artifacts. It illustrates a macro trend. Natural events are triggering earlier. We see earlier opening of leaves, premature return of birds, and early emergence of butterflies. Ecologist Perry Root uses a methodology that takes this historical data and moves it from showing the past to forecasting the future. She started by extracting decades of wildfowl counts taken by amateur birdwatchers between 1955 and 1996 on seasonal ponds in the American Midwest. Root then combined these historical bird counts with modern climate data and projected future warming models. Her resulting forecast reveals that the increased droughts predicted by these models could effectively halve the breeding waterfowl populations in those areas. These ad hoc historical observations function as the hidden engine generating concrete warnings for species conservation. Despite these results, there is significant professional friction. Many scientists simply refuse to touch amateur datasets. The core vulnerability of historical ad hoc records is the inherent subjectivity of the human observer. Different observers can have vastly different interpretations of what exactly constitutes an open snowdrop flower. Observing the exact day a leaf appears is a fairly simple visual metric, but judging the exact onset of autumn leaf color change is a highly subjective process. Raw, unstandardized observation produces noisy data, requiring rigorous filtering before it can be deemed scientifically valid. The first layer of quality control involves researchers manually interviewing collectors to weed out flawed records, like a set of measurements skewed simply because the observer went on a family vacation. This scatterplot illustrates a noisy dataset from thousands of amateur records. To solve this mathematically, Arnold van Vliet applies specific statistical techniques. Overwhelming volume cancels out the statistical noise of individual idiosyncrasies, revealing a clear, undeniable trend line. With enough data points and the right statistical smoothing, Anecdotal human error is mathematically converted into hard scientific signal. Looking ahead, the discipline of phenology is shifting. Researchers are moving away from ad hoc diaries and establishing standardized recording schemes for today's amateur observers. Enlisting an army of citizens offers a triple advantage for data collection: vast geographic breadth, deep historical timeframes, and low collection costs. There is also a sociological benefit, because these records are based on local, tangible observations that the public already understands. Involving them in the collection process empowers citizens and helps bridge the gap between abstract climate modeling and public acceptance. Predictive ecological modeling requires both the processing power of supercomputers and the organized everyday observations of millions of ordinary people. This video is brought to you by the IELTS FOCUS Zalo 0847705973, an English center specializing in IELTS preparation.